Hello everyone, today we're going to be working on fundamental problem 4.26, and this problem is asking us to replace the loading system by an equivalent resultant force and couple moment acting at point A. So as you can see, we have point A right here with our three forces, 1, 2, 3, and it's given our our forces, the value of our forces, 35 newtons, 30 newtons, and 55 newtons. So the first thing that I'm going to do is I'm going to be taking force 3 and I'm going to be splitting that up into our x and y component. So we're going to have that vertical force going downwards since it's slanted downwards, and that horizontal force going to the right since this is also slanted to the right. So the first thing that we're going to do is do that. So let's start with that. So the first step is finding our y component. So f of 3, but in the y component is equal to the 55 newtons times, we're going to multiply that by 3 over 5 because it's given to us here this is a 3, 4, 5 triangle right there, or a 3, 4, 5 slope. So since we're using that force of the horizontal side, that's why we put the 5 at the bottom, and we're trying to find the vertical side, which we know that it's a side of 3. So we're going to multiply that to find our vertical component. So we have 55 times 3 over 5, giving us that f of 3 of y is equal to 33 newtons. Now we're going to be doing the same thing for our x component, but this time we're going to be multiplying it by 4 over 5 since now we're dealing with the horizontal side. So f of 3 of x is equal to 55 newtons times 4 over 5, giving us a value of 44 newtons. So f of 3 of x is equal to 40, yeah, 44 newtons. So now that we were able to determine our x and our y components, so basically we have this force right here of 33 newtons and this force right here of 44 newtons. So the next thing that I'm going to do is I'm going to be taking the sum of all our forces in the same direction. So I'm going to be adding up all of our forces in the x direction, and then I'm going to be adding up all of our forces in the y direction. So number 2, as you could see, there is only one force in the x or horizontal direction, which is the 44 newtons. So we don't really have to sum anything to it. So we could just put that our f of r of x is equal to 44 newtons going to the right. From there, we do have to sum up for our y-axis. So remember your sign convention, upwards positive. So f of r of y is equal to, and you could see that all of our three forces are going downwards, so they're going to be negative. So we're going to have negative 35 minus negative 30 minus negative 33. So let's write that out. Negative 35 minus negative 30 minus negative 33. So that should give us a total of 35, 30, 33. That should give you a total of negative 98 newtons acting upwards. So that means that our force in our y direction is equal to 98 newtons acting downwards. So now that we have our x and y force, what I'm going to do is I'm going to draw out a sketch to be able to then determine our resultant force and then its direction. So we're going to have our y-axis, our, our x-axis. So this is x, this is y. As you can see for our x-axis, we have 44 newtons going to the right. So we're going to draw that out, which is about here. 44 newtons going to the right. And for our y direction, we have 98 newtons going downwards. So we're going to draw that out too. So as you guys could see, 98 newtons. Our resultant force is going to be somewhere right here, about right here. So we're going to determine the magnitude of that resultant force. So remember our resultant force. So step 3, our resultant force is equal to f of x squared plus f of y squared, taking the square root of that. So our resultant force is equal to 44 squared plus 98 squared. So we're going to plug that into our calculator, giving us that our resultant force is equal to 107.42 newtons. So that is our magnitude of our resultant force. But now we also have to determine the direction. So you could find its direction either counterclockwise or clockwise, however you guys want. So from the positive x-axis, which is right here, you can either go counterclockwise, right there, or you could go clockwise. It would be easier to find it clockwise, but you could also find it counterclockwise. Basically, it finding it counterclockwise would just take one more step, because what you're going to do is first you're going to find this angle right here. From there, if you're trying to find it clockwise, well then you would just put that it's that angle going clockwise from the positive x-axis. But if you're trying to find it counterclockwise, what you're going to do is you're going to take the angle that you found right here and subtract that by 360, since it's just that. So you'd be subtracting that angle from the total 360. I'm going to find it, we can do it both ways. I'll write it out for both. So, but to find it, what we're going to do is we're going to draw the force right here. We know that this force and this force have the same value, so 98 newtons. And we're trying to find this force right here. We'll call that phi. So since we know this side and this side, we can use tangent theta, or tangent phi is equal to the opposite over the adjacent side. And that's how we're going to be able to determine our angle right there. So tangent phi or tangent theta, whichever symbol you want to use, is equal to opposite over adjacent. So we would end up getting that our angle is equal to the tangent inverse of our opposite side. Our opposite side is the 98 newtons over our adjacent side, which is 44 newtons. And then we're going to input that into our calculator. You want to make sure that your calculator is in degrees. So tangent inverse of 98 divided by 44. You should end up getting that your angle is equal to 65.82 degrees. So this would be the direction of your resultant force if you were trying to look for it clockwise from the positive axis. So this can be your direction, but you got to specify it. Don't forget to specify in which direction. So this would be your answer if you were finding it clockwise from positive x-axis. But if you were told, or if you want to find it going counterclockwise from the positive x-axis, you would still need to do this part, but then from there, what you would do is you would so that we call that angle phi. So to find theta, which is the answer that you're trying to find, going counterclockwise from the positive x-axis, what you would do is you would take 360 degrees and subtract that angle that you found, giving you an angle of 294.17 degrees. And now, so your theta is equal to 294.17 degrees going counterclockwise, sorry, counterclockwise from positive x-axis. So either or is correct. Remember, it doesn't matter. It's depending on if your if the problem is asking for a specific way. Either way, you could do it both ways. Just remember to specify if you found it going clockwise or counterclockwise from the positive x-axis. So remember, this problem asked us to replace the loading system by an equivalent resultant force, which we did. We found out that the magnitude was 107.42 newtons, and its direction, either going clockwise from positive x-axis, was 65.82 degrees, or going counterclockwise from positive x-axis was 294.17 degrees. Now we just have to replace the loading system by an equivalent couple moment acting at point A. So to do that, what we're going to do is we're going to be taking basically just the moment about point A. So that's going to be our last step. So step 4, if I'm not wrong. Step 4. Remember sign convention, counterclockwise positive. So our resultant moment about point A is equal to, we're going to start off with our moment that is already given to us, which is right here, of 200 Newton meters. And as you can see, that is going clockwise. So that's going to be a negative moment. So we have negative 200 Newton meters. From there, we have our force one that is lying parallel to that vertical axis. So we know that's not going to be creating a moment since, remember, moment is equal to the force times the distance. So our force would be that 35 newtons, but our distance is equal to 0, which is why it doesn't create a moment. From there, we have our force 2. That is going to be creating a moment. It would be creating a clockwise moment, meaning it's going to be a negative moment. Our force is 30 newtons, and our distance is going to be this 3 meters right here. So let's write that out. Remember negative moment. Negative moment, so a negative 30 newtons times 3 meters. And then from there, right, 30, yeah. And then from there, we have our f of 3, our y component of it, of 33 newtons. As you can see, this one's also going downwards, so it's also going to be creating that clockwise moment, meaning a negative moment. But our distance for this one is going to be 6 meters since it's this 3 meters plus this 3 meters, giving us a total distance of 6 meters. So negative moment of 33 newtons times 6 meters. And then our horizontal force is not going to be creating a moment since it intersects that vertical that vertical axis. Remember, Moment is equal to force times distance, and our distance here would be 0, so there is no moment happening with that force. So we're just going to find our moment here. So we end up getting negative 200 Newton meters minus 90 Newton meters minus 198, 198 Newton meters. Now we're just going to add that up. So our resultant force about point A is equal to a negative 488 Newton meters going counterclockwise, meaning that our resultant moment about point A is 488 Newton meters going clockwise. And just like that, we were also able to replace the loading system by an equivalent resultant moment acting about point A. So remember, our magnitude was 488 Newton meters. Our direction is clockwise. So remember this problem was asking us to replace the loading system by an equivalent resultant force and couple. So our resultant force is right here. Our direction of our resultant force are any of these two. And then from there, our resultant moment is right here. Please feel free to like this video, and also please feel free to subscribe to our channel if you guys would like to see more videos like this.